Thank you very much, Diane. And thank you to all the participants there, and a special thank you, of course, to Professor Prof Pournara, who is presenting in this particular seminar. So my job is simple. It is to in fact, introduce someone I've known for 19 years. Prof Pournara is an associate professor of mathematics education at the Wits School of Education. He has been part of the Wits Maths Connect secondary project team since 2010 and is currently the project director for the project. He led the professional development work and also led several research projects within the larger project. And this is something you'll find interesting. Craig longs for the day when more learners can do mathematics because they can make sense of the mathematics they are doing. And he also longs for the day when more teachers can teach mathematics because it makes more sense to them too. And he does what he does to make these two longings a reality in his lifetime. Unfortunately, I'm not present there to see how many people are smiling. And maybe even if I was present, the mask would have prevented me from seeing you smiling. And that is a clear sign that COVID-19 has impacted on many spheres of our lives, including teaching and learning, mathematics not being an exception. So this morning, Craig will be presenting on a study in which he embarked on to investigate the impact of COVID-19 on the teaching and learning of mathematics. And the seminar, of course, as you know, is entitled, "What is the impact of COVID-19 on school mathematics performance?"
Thanks, Tony, and good morning to colleagues who are here in person and to colleagues who are online. I am wanting to forward, there we go. So, Tony, I can't believe that it's 19 years that we've known each other. That's something I didn't know until 5 minutes ago. So, colleagues, I want to say thank you to the Center for the opportunity this morning to share. I hope that what I'm going to share is interesting, but I hope more importantly that it actually spurs us to action. Because as Tony said, I do what I do because I want to see change, more so than I'm doing what I do because I just want to find out something from research. So I'm particularly interested in how we make research count beyond just the findings that we have. Let me start with just giving you a brief idea of what I'm going to talk about and the structure of the presentation. I know that Jill Adler presented about the Wits Maths Connect secondary project and her Saatchi chair in August last year. And so if you have heard that presentation, you will know something of the project. I'm not going to talk about those details, but pretty much everything that we have worked on has been informed by those first 10 years. And so in some ways, that work and the stuff that Jill talked about is here, but invisible in this entire presentation. So let me just give you briefly the WMCS, as we refer to it. The project goals are, like so many other intervention programs in this country, to improve the teaching and learning of mathematics. We have particularly focused in the last 8 or so years on grades 8 and 9, and particularly the teachers who are teaching at that level. And our goal is that more learners will be able to choose mathematics in grade 10 and succeed at it. There are many learners in this country who choose mathematics in grade 10, but they don't succeed. And that's not a helpful statistic. And obviously in the university context, we want more learners gaining access to the mathematical sciences at university. So although our focus has been grade 8 and 9, our trajectory has been to prepare learners to be able to access university mathematics or the mathematical sciences more broadly. Our focus has been on disadvantaged, under-resourced, no-fee, low-performing, whatever you want to call them. We kind of have a picture in our minds of what those schools look like. And we have a picture in our minds about what other schools look like too. And I think we might get some surprises about that today. So the Diva project, which I'm going to give you, which is what it's going to form the focus of the empirical work of this presentation, started with some driving questions that are kind of kicked off by COVID. So what mathematics do learners bring to high school? To what extent are they prepared for algebra when they enter high school? And what's the impact of COVID-19 on the teaching, the learning, the knowledge that learners have of mathematics? Diva comes from diagnostic and baseline, and I'll say a little bit more about that in terms of our goals. We wanted to develop a test instrument that would assess learners' knowledge and skills at the end of grade 7. So in South Africa, that's end of primary school and or the beginning of grade 8. So it's really trying to get at that interface between the end of primary school, beginning of high school. We wanted an instrument that could provide a baseline measure in some way, but also diagnostic data on learners' errors and their misconceptions. So while this was triggered by COVID, it is in no way limited to COVID. And of course, testing is just the beginning of the process. It's really what we do after the testing that's going to be more important at the end of the day. I want to give you some background on the test instrument and share some of the items just so that you have a sense of what this thing looks like. The mathematical content is from grade 4 to grade 7, and we deliberately went all the way back to grade 4 because we know about underperformance. We know that there are many learners in grade 8 and grade 9, and unfortunately beyond that, who are not on top of primary school mathematics. And so we wanted to start low down and get a sense of what learners can do as well as what they can't do. The final version of the test is 65 multiple choice items. Learners are given 60 minutes to write the test. We piloted the items in 2020 in term 4. We worked in 15 township schools. So you can imagine what this was like, because late 2020 is schools are already higgledy-piggledy in relation to COVID. We had 10 primary schools for grade 7s, 5 secondary schools for grade 8s. And the table there shows you the breakdown of the final version of the test. The pilot test was slightly different, but that's not in focus today. So you can see the vast majority of items focus on number, either whole number or rational number. And then there are some on functions, algebra, and pattern, a few on measurement, and even fewer on geometry. So I'll just give you a minute or so to take a look at that screen, which gives you an idea of some of the items that were in the test. Obviously, this is a selection, but it gives you a feel for the kind of range and the kind of level that we were testing it. And it's very hard to know how long people need to see so much text on the screen. But I think given that we all come from a mathematical space, probably you just needed to take a quick look and you know what it's getting at. So learners wrote the test, filled in multiple choice answer sheets, the classic kind. It was marked by an online learning system, which generated a spreadsheet, which we then pulled into an analysis tool, which still happens to be a spreadsheet. We cleaned the data and we generated summaries and school reports. I'm going to come back to this thing of school reports right at the end because we think this is an important component of the work that we've done. It's not just about the research, it's about reporting the research and giving teachers and schools access to what their learners have done through the instrument. The school and learner sample, just heads up, this is going to take a while to explain. For a bunch of reasons that will become obvious. We tested grade 8 and 9 learners in term 1 last year, 14 secondary schools in Gauteng. And as you'll see, I have distinguished 3 different clusters. Now, the clusters are not geographic regions, which is typically how clusters are talked about in schools. I'll explain what I'm meaning by those now. You can see the number of learners, the majority in cluster B, and very few, in fact, in cluster C, which are the township schools. Now that is a story on its own, but for another day. But let me give you some understanding of what these clusters are. So cluster A are Quintile 5 schools. They are X model C. If that language makes sense to you, they are high performing. And so some of these schools are the top feeder schools to Wits University, and inevitably then possibly top feeder schools to other universities in the country. So these are the schools, 100% pass rate, 100% pass rate in maths, probably many distinctions. They've got lots of resources.
So cluster A is what, like private schools?
No, these are all government schools. Okay, they're all state schools. Thanks for that. Cluster B are Quintile 4 and 5 schools. They are also ex-Model C schools, which gives you some sense probably of what the buildings look like and what the resources are that they will have in those schools. The majority of learners, however, come from poor communities. And that's going to be critical in the research that we did. Cluster C are township schools, and that label in and of itself kind of conjures up something in your head automatically, right? Overcrowded, under-resourced, and a whole bunch of other things probably. These schools would be classified as Quintile 1 and 2, and these are the typical schools that we worked in the project since 2010. Now, the Quintile labels are actually not all that helpful, and I want to rather work with the ideas that Crane Sudin has proposed. In his address at the Sierra conference in 2021, he classified these 3 clusters. He didn't use these clusters, but the language he used I found really helpful. He talked about cluster A as having many resources at school and at home. And in the context of COVID, that is very important. By contrast, cluster B had resources at school, but few resources at home. Probably no Wi-Fi, probably no unlimited data, possibly no computers, but they have all that stuff at school. Cluster C have few resources at school and very few resources at home. They may not even have a desk where they can sit quietly to work on. And so they would choose to go to school in order to have a quiet space to do their work. So these 3 classifications will turn out to be important as I go through the presentation. Right, overall performance. The box and whisker plot there gives you a sense of how these 3 different clusters performed, and really it's not particularly surprising. There's nothing earth-shattering here at one level. Cluster A average roughly 60%, cluster B 36%, cluster C 26%. When we start looking a little bit more closely and kind of, I'm doing this at a, if you want, a not so mathematical level, the middle 50% of learners in clusters A and B hardly overlap. Okay, so these are both learners in Quintile 5 schools, most of them, but they hardly overlap. That turns out to be important. And then 75% of the cluster B learners fit into the same mark range as the bottom 25% of those top schools. Yet they are all called Quintile 5. Okay. The performance per topic, I've still kept with the same color coding, so hopefully that helps you. There you can see per topic the same trends across all 5 topics. The performance on the measurement items was poorest, as you can see. And sorry, those numbers at the top are the number of items per topic, just to clarify. The measurement performance has been the poorest topic every time we've used this test on many different samples. And what's interesting to note is cluster B's performance on measurement items is relatively weaker than their performance on the other topics. So now if we take a look at the entire distribution, so this is all the items, and they're organized according to their position in the text. So on the left is item 1, on the right is item 65. I'm not sure how much you can see of those tiny numbers. The green graph is cluster A, the blue graph is cluster C, and because I want to zoom into cluster B, I've made that one red now. As you can see, the trend pretty much the same. Okay, overall, it doesn't look too different across the 3. The stuff that's difficult for one group, for the most part, is difficult for the other. But as you look towards the right-hand side of the graph, you see that the red and the blue get closer together than they were on the left-hand side. And this is something that turned out was a big surprise to us, because it was what's going on here towards the end. Well, what we started to realize as we dug into it is that learners in cluster B were not getting to the end of the test. We didn't pick this up in the pilot because we only piloted in township schools. So I'm not sure how well you can see those numbers, but if you notice the red numbers, those are percentage of learners who are not answering those items. And these are, so this, as you can see, is from item 45 to item 65. So the last 20 odd questions of the test, right? Towards the bottom, we've got like 30% of learners are not getting to those items. By contrast, in cluster A, the maximum is kind of 8% in any one item. And I've deliberately included the percentage correct there because it shows you that this is not connected to how well they performed on the item. It's irrespective of that. Cluster C, surprisingly, has the similar profile in terms, and in fact, it's even smaller, numbers of blank responses. And yet the performance was really poor, right? Now, this is not new. In TIMS, from the early days of TIMS, we saw in South Africa, learners don't like to leave blanks in a maths test. They put something there, even if it's nonsense. So in a multiple choice test, clearly they're just going to put across somewhere. But the cluster B learners didn't. The cluster A learners seemingly didn't need any more time. Cluster B learners, clearly there's a whole story going on here that we didn't anticipate. So now what I've done is I've adjusted the yellow graph to show, so this is now adjusted, instead of the denominator being the number of learners who were in the sample, it's the number of responses per item, okay? But I've only adjusted for cluster B, because for cluster A and C, it wouldn't really make that much difference. And you can see there towards the right-hand side that the gap now starts to grow. It hardly makes any difference. The red and the yellow graphs are very similar in the beginning because there are very few that are left blank there, but towards the end, it made substantial difference. And it's actually statistically significant using the paired samples t-test, just looking at the raw score for cluster B and their adjusted scores. So this, I want to do a little aside now and talk about the quintile system, because I'm not sure how many people in this audience will be familiar with some of the details of it. It's essentially government strategy to redistribute financial resources in the education sector. It's been part of the plan all along, but the way it's operated has changed. So funds are allocated to a school based on the poverty or affluence levels of the community in which the school is located. And I've deliberately put that in red because it's about geography, not about demographics. Okay, that's really important. So the problem that we now face is that there are many learners from poor communities who attend school in wealthier areas. Okay, that's essentially the cluster B group. And so the school gets a lower subsidy, and I'll come to that now, but they can't charge higher fees because the learners can't afford it. And so the school sits in this catch-22 situation where the learners, they're classified as quintile 4 or 5, which means you get a low subsidy, but they can't be hiking their school fees because they won't get anything as a result. And of course, all of this is exacerbated by COVID, during COVID and now post-pandemic. What you can see in this table is the quintiles and the blue or gray, I'm not sure what color it appears on your screen. Those three, quintiles 1, 2, and 3, you can see get the highest subsidy in ZAR as in South African rands. And in 2008, the figures that are on the screen indicate the discrepancy and or the differences, okay? Quintiles 4 and 5 are fee paying, the others are no fee schools. More recently, the policy has changed. And so instead of having a differential between the quintile 1, 2, and 3 schools, they now get the same amount of money, which actually is fairer because distinguishing quintile 1 from quintile 2 is almost impossible anyway. And so this kind of works, I think, more fairly in that space. But take a note at the difference between quintile 4 and quintile 5. 735 Rand in 2021 per learner in a quintile 4 school, whereas only 250 odd Rand in a quintile 5. Now in high-performing, well-resourced quintile 5 schools, it doesn't really matter because that is a tiny proportion of the school's budget. Lots of money is coming in from school. But in an under-resourced or school where parents can't afford that, they're not getting much more. certainly not in COVID, as those figures that you see on the screen. So those schools are sitting in a really precarious position. And my understanding, and some of the stuff I've read in the popular press recently, suggests that it's getting worse this year, from last year and this year. So, to pause and say, what's the key findings of what we've seen so far? Firstly, the COVID-19 pandemic exacerbated the maths crisis. I don't like the term, hence it's in inverted commas. The problems were there all along, it's just made them worse. That's no surprise. Performance across the different quintile groups is considerably different. That's no surprise either. If you look at matric results, you see the same thing as well. No surprises there. But the performance within the quintile 4-5 band was considerably different. And that, to some extent, starts to become something certainly that we didn't know. And with hindsight, it kind of feels maybe like common sense, but common sense and 20/20 vision. It's all about hindsight in many ways. So what's clear is that learners in that cluster B group would have benefited from more time, but we don't think the cluster A or cluster C learners would have benefited that much if they had had more time on it. So the implications here in relation to quintiles is there's a need to distinguish quintile 5 schools in terms of the demographics and not the geography. That is clear, and people have been saying this for years. This is nothing new. But it kind of comes home here in the COVID context, where kids are going to a school with resources, but living in a home with very few. So they didn't have access to online learning. They may not even have had a cell phone at home during the time, because the parent might have had it at home. I've spoken to teachers in schools that fall into this cluster who said to me, when you lose your job and you have no food on the table, you sell your cell phone in order to get money to buy food. That's some of what's going on in these schools. Okay. There's also a need for us to challenge this dismissive discourse, my phrase, about quintile 5 schools. When you read the academic literature, there's a lot of it that kind of dismisses quintile 5 as saying they've got resources, they sort it out, everything else needs to be focused on from quintile 1 to quintile 4. I don't want to undermine the importance of paying attention to quintile 1, 2, 3, and 4 schools. But I really do think we need to be careful about dismissing, particularly the quintile 5 schools servicing poor families. And I think universities are going to see some of the consequence of this in years to come. Many students who come to university, and I think who do mathematics, come from those schools. If those schools are not supported more to overcome some of the COVID stuff, I'm wondering whether those learners are going to make it in the way that they used to. I'm crystal ball gazing in some way, but I think that it's something we need to look at. And it's not just about secondary schools, it's also about primary schools. Because remember, we tested grade 8 and grade 9, and the grade 8s in January, February last year were really just coming from primary school. So really what we're testing is what they brought from primary school. And so it's the primary school story that needs to be considered. So another question that we asked ourselves in relation to COVID was, is there a difference in performance between the grade 8s and the grade 9s? And the reason we asked it is that in 2020, grade 7s went back to school first, along with grade 12s. And the grade 8s were the last to go back. So in terms of opportunity to learn at school, on site, the difference is quite a few weeks. Okay, and these are in a sense notional weeks, because the reality is that at the same time as all this is happening, we have rotational learning, which means that learners may go to school every second day or in alternate weeks. But what we saw on the ground, and this is anecdotal, is that for many grade 8s in 2020, they got on average 1 hour of mathematics a week. A week, not a day. Because, so imagine in a township school, you have got 300 learners. You've now got social distancing and all this stuff going on. So grade 8s are coming to school, one group at a time, but it's only like a third of them. So every third day, maybe. And you can't have every subject every day because the day is not long enough. So maybe you get maths for one period in the week. And then we're surprised. right? So despite government's intentions, what happened on the ground is not necessarily what we hear reported in terms of what was going on during the latter part of 2020 and quite frankly also 2021 for many schools. So we kind of wondered, is it possible that the grade 7s are going to outperform the grade 8s? And this I'm meaning grade 7s in 2020, right? So that translates into saying, is the Diva performance of grade 8s at the beginning of 21 possibly better than the grade 9 performance at the beginning of 21? Simply because they had more opportunity to learn. Now, it was a question you kind of think, let's take a look and see. At one level, you want the answer to be no, right? But if you get a yes, then actually you've got something interesting. So there's a love-hate relationship with doing this investigation. So I'm going to focus on cluster B schools particularly because the numbers there were bigger in terms of number of schools, but also in terms of number of learners, and comparable in terms of numbers too. So as you can see there, roughly 1,250-ish learners in both groups. And I'm pausing because the clicker's not moving. When we look at the overall score, the difference in overall performance is statistically significant. Whether that's really that important, I don't know, but it's something that's worth paying attention to. It was statistically significant. What we noticed there in measurement is that there's very little difference. And typically that comes from the curriculum where the trimming of the curriculum said kind of leave measurement till the end, which typically meant they didn't get it. So it wasn't taught. And that's why there's very little difference. I just want to compare cluster C briefly so that you get a sense of how these cluster B schools are performing in relation to the township schools. But bear in mind, the township schools, it's few of them and the numbers are really small. As I said, that collecting data in township schools in the first term last year was incredibly difficult. And at the end of the day, we had to cut our losses. We expected roughly 4,000 learners to participate, and we got less than 1,000, way less than 1,000 at the end of the day. Very, very long story, no time to talk about it more now. But what you notice there in the township school is that the average scores are not far closer together. That surprisingly, the measurement is reversed, so the grade 8s actually perform better than the grade 9s. And that may have had to do with what got done in grade 7. And then the gap in geometry is very small. Probably also because geometry wasn't taught in 2020. What I'm going to do now is go through some items so that you can get a sense of what learners were doing. So this kind of gets inside the test, inside the errors, and gives you some sense of what's going on. So the selection of items hopefully gives you a bit of a range and a feel for what learners did. So understanding the equal sign as balance is a key issue in making sense of equations. We know from our previous research that this is an area of weakness. And so these are items, well, lookalike items from the test. And what you see there in blue compared to the black, which is grade 9, very few or not enough learners are getting the answer correct. Many of them are being seduced into 5 plus 3 is 8. In other words, equals tells me to write the answer, and they ignore whatever else is on the right-hand side of the equal sign. So very typical wrong answer. It's in international research. It happens all over the world, but it also gets worse somehow with the subtraction. And again, this wasn't a surprise to us because we've seen it in previous research we've done, but we can't kind of entirely understand why it makes such a big difference. And it's both grades, right? Roughly 20 percentage points in both grades. I'm looking for tech help here because now the point it doesn't want to talk. There we go. Okay, so most learners have a do something view of the equal sign, meaning you work from left to right, you write down the answer. What they need is this equivalence view to see it as balanced. Okay, now for mathematicians and for even FET math teachers, it's kind of like this seems utterly trivial. But it's clear that it's something that needs attention in primary school and in the bottom part of high school as well. The other thing is that it seems that this equivalence view is not stable because there are learners who are getting it correct for the addition version, but they're not getting it correct for the subtraction version. So there's something going on there that needs more attention as well. Okay. This item, I think this was one of the ones that was put up earlier as well as an example. So we're trying to head now towards property of number, moving from whole number towards generalizing and algebra. Okay, so the distractors that we give the learners are important, and typically 0, the number itself being star or whatever, and 1, and then impossible to tell. That was an option we gave them. As in, I don't know what the number is, therefore I can't tell you what the answer is. We were expecting that that would be a way of reasoning. And I've also included in most of these coming from now, the percentage blanks, so you get a sense of how that's working. So there you see, 22% of grade 8s, 28% of grade 9s, not much different. In terms of blanks, a lot more grade 8s, grade 9s, it's a little bit more familiar. But very few learners are generalizing this idea of anything divided by 1 is itself. That's clearly not there yet. And we're talking about learners who are at the beginning of grade 9, and we would expect them really to be coming to high school with this knowledge. Another one, which fraction is equivalent to 12%? We know from other research that learners' knowledge of percent is really, really good. And the connection between common fraction and percent is no different. So of course, what is seductive here is that there are 3 distractors that all have 12s in them, but the correct answer doesn't have a 12 in it. And so of course, this influences how learners respond. And so we see there 25%, roughly 35% of grade 9s are choosing the right answer, but there's a focus on looking for 12. And so, and of course, many grade 8s who left it blank. But approximately 60% are choosing a distractor with 12. They're expecting the answer to contain 12 and not really paying attention to the denominator and the numerator. Possibly, it may be that actually this item just was so seductive around the 12s that that's what caused this particular distribution. Looking at fractions and ratio, it's really important that you see the picture and the distractors here, because what we know is that learners don't pay attention to the order in ratio at primary school level. And we also know that they focus on counting rather than looking at the proportions and working with an idea of ratio. So you can imagine which is the most common answer here, I'm sure. But maybe you wouldn't have expected it to be nearly 60%. 15% of grade 8s choosing the correct answer, but nearly 60 are choosing 3 to 6, which is saying that they're counting the items and they're not paying attention to the order in the ratio. Multiplying fractions with different denominators. This item we debated a lot when we designed it because it's quite hard to get 4 distractors on these kinds of problems. So when you see a question like this, you're probably expecting the answer to be a common fraction. And so that's what we got in the results. Even though neither of those first 2 distractors are correct answers in any way, except that they have the right denominator. So, sorry, they have the right denominator. So to some extent, they've got something correct. But the numerators are both wrong. But learners are choosing those. Now, whether they're choosing it because they know the other 2 can't be right, or whether they can't do that, they're just saying, there's a 21 there, that's my cue. We're not sure, but we suspect that might be the case. They're just looking for something that looks like it could be right. High percentage of blanks here because this item was quite deep into the test. Okay, this item on perimeter was very surprising to us. So you'll notice that the numbers there are 4 numbers given on the diagram, which in effect means that there are 2 sides where the lengths are not given, but they can be inferred. And we kind of thought this is a pretty typical textbook task. Learners will know what to do here. So they're the 2 sides that they need to work to add into the answer, but around 60% chose the first answer. So they're looking at the diagram, they're adding the numbers, they see it's one of the options, and maybe the fact that it was the first option pushed them towards choosing that distractor, but very dominantly ignoring, not paying attention to the details of the diagram. High percentage of blanks. That will explain why the numbers are not getting anywhere close to 100. Okay, this one kind of heading towards algebra, but something that learners would have encountered in primary school. We're wanting to know the value in the box, and we're really wanting to see how are they interpreting the brackets, because we could have left the bracket out. But by leaving the bracket out, we wouldn't know whether they're treating the box as a digit or as a number. Well, that could be a possible confusion in the interpretation. Very big difference here between grade 8 and grade 9. And that's not surprising, because much of grade 8 would involve getting familiar with algebra. And so there's certainly something that the grade 8s learned when they were there in 2020, which is reflected in 2021, but it's only 50%. And of course, that's hugely problematic. But very dominantly in terms of an error, seeing that bracket has been treated as addition. We're putting a 12 in there. Somehow we're adding it to 3, and then we're adding 4. Am I right? Yep. And that gives us 19. Another example from algebra. Which of the expressions represents that verbal statement? So we gave them 4 different ones. Correct ones highlighted in green. Improvement from grade 8 to grade 9, but notice the dominance of that choosing the first expression, which suggests that learners are translating directly from the words to the symbols. And so they're ignoring the order of operations, and they're not paying attention to the structure of the algebraic expression. And that obviously is something that is critical and something that needs to be addressed. And of course, then looking at the equivalence or non-equivalence of those different options that are given there. So, general conclusions on the Diva performance. Now, not all of the things that are on the screen are things that I've talked about, but I wanted to give you just a sense of what we saw. Strong evidence that learners don't have the basic knowledge to cope with introductory algebra. And in a sense, it's not new. Small gains in fluency from grade 8 to grade 9. Rational number items are poor. There was repeated evidence of learners focusing on the visible features of test items. So the 12, for example, in the percent, the diagram with the 2 missing lengths. Classic cases, we saw that over and over again in items with diagrams. Measurement items, while we weren't expecting the performance to be so poor, we're not sure whether this is connected to the fact that it may not have been taught. But what we do realize is the implication that if the measurement knowledge is not there, it impacts not only mathematics, but it impacts the other areas as well. Natural science, geography, technology, a whole bunch of stuff, just in grade 8 and 9. Never mind what it's going to do coming later on. Oh, yeah. Okay, so the next step, sorry, I'm just checking what I missed, nothing. I'm going to close now with this section on what I think are next steps. And I think that there's a lot of next steps that are possible, but what I want to do is choose a limited selection and kind of dig into them a little bit. I think that we need to explore much more carefully the diversity of Quintile 5 schools and understand better what's going on there. So are the findings that we had amongst this group of schools, so we had 6 of them, but we've seen it more broadly in other schools, is that the case on a larger scale with a more diverse sample? We need to know that, and I think government needs to know this. We also need to think about this issue of learners not completing the test. Was that linked to the pacing? Is that linked to teaching? Is paced more slowly in these schools? I don't know. And there's also an issue about pacing when you take assessments. So is it both aspects or is it only one of them? I think both those things need attention. The other is this issue of addressing gaps in learners' mathematical knowledge. Again, this is not new, but it's been exacerbated by COVID. And I stand here myself saying, I know that I don't know how to do this. I have some ideas, but I don't know what it takes to address the gaps in learners' knowledge in the realities of the typical classroom, and at the same time move forward with the curriculum of the grade I'm supposed to be teaching. That is what teachers are required to do. And that when you work in a school where the majority of learners are not on the page, then how is it that you're going to manage that and move them forward? Maybe it's an impossible ask, but we need to research. This is an empirical question that needs to be engaged with and to understand what the special knowledge is that teachers need in order to do this. I don't think we know in this country, or frankly internationally, how you do this in the context, particularly in under-resourced contexts. And when we have the answers, and we can't afford to take ages to get there, right? We've got to build this stuff into initial teacher education and into continuing professional development. It's not just about saying this is what learners can't do and they should be able to do it. We've got to find strategies and we've got to teach these as a specific part of the curriculum that teachers are learning, either in their pre-service teacher education or in professional development. It's not just about how you teach the stuff, it's about how you work with these gaps to close them and keep moving forward in some way. Another thing which we think is key is identifying the most common errors. So you will recall the results from this item, where the obvious problem is learners counting the items and not paying attention to the order. Similar kind of dominant error occurred in that algebra example. I've started to call these standout errors, and I'm defining it as an error that's much more frequent than the incorrect responses to the same item. So literally it stands out because the number is bigger than all the stuff around it, okay? And I think that if we address those errors first, at least we give teachers and learners some quick wins. They get to see some improvement. Now, those two examples that I've got on the screen are not straightforward to fix because there's conceptual stuff that's going on. The example there with the diagram of pay attention to all the sides is a much quicker one to fix. But the other two are more substantial and they stand out, even though the sizes of them relative to each other may be different. The other thing that my colleagues and I have been trying to think about is teaching strategies that we can share with teachers. So when you are trying to teach primary school maths to grade 8 and 9 learners, can you do this in a way that fast tracks things? And it's similar in university. Students coming into university who haven't got on top of all their high school knowledge, there's got to be ways of teaching it faster. You can't go at the same pace as what they would have learned at school because you'll never finish anything and you won't get through the new stuff. So this diagram that I'm putting up here tries to give some sense of that. If we think, just for the example, of breaking up whole numbers with the idea that we want to get a network of constants. So breaking up in an additive way, we're talking about place value, we're talking about bonds, we talk about what we call friendly numbers in the school context, and friendly because they're easy to work with in order to do particular things. So seeing an additive way of breaking numbers up and distinguishing that from a multiplicative way, where we've got factors, we've got prime factors, we've got exponents, that those are connected, or two pieces that are then connected by the idea of grouping, and that grouping is the connection from addition to multiplication. Now, for university lecturers, this is clearly not the space that you work in, but we know clearly that there are learners coming into grade 8 that do not have this. And so paying attention to this and trying to fast track it, we think is really important. The other thing is about teaching strategies that help teachers to work with powerful representations that develop number sense, that develop conceptual understanding. So what I've got here are two examples of using the empty number line in ways that are promoted in primary school. But we are seeing grade 8s and 9s who do not know this, and are struggling to add even those numbers. The curriculum revision, it's clear that the curriculum needs to be revised, and I want to give an example of how we think this might be done. So there are topics we think that can be removed, there are demands we think can be reduced, and there is clarity that's needed in the scope. So I've given some examples there, and the principle we're working from is that you don't introduce very briefly in a lower grade mathematics that's going to be done in detail in the next grade. That's the principle we work from. In addition to that, and I know I'm treading on thin ice in this with this audience, we recommend that all statistics should either be taught in grade 8 or grade 9. There's so much repetition, you don't need to do it in both grades. The progression is not clear. Like, do it in one grade and let schools choose it. Then maybe the one that's going to get my tires let down is to say, take out probability from grade 7, 8, and 9. We're not saying it's not an important idea. Of course, it's important. But given everything else, it's taking up time, and it's been taught badly because teachers don't understand it themselves. So our take is, take it out. And then guard against going too far with stuff, with exotic examples that you're never ever going to use. There's lots of this going on, where you have crazy examples like HCF there, which you're never going to use when you actually need to use to work with that concept. Okay, next steps in terms of advocacy and policy. I think, as I've said, we need greater attention to the Quintile 5 issue. The second one is around widest, I don't know if widespread is a word, but I'm using it anyway, of Diva type tests. That schools get ownership of these tests, that they can use them in ways that they want, and that we provide, where possible, online functionality that learners can answer them online, or paper-based versions where that's necessary, and that we provide a system and a dashboard that supports teachers. And I'm just going to show this last slide, if it will come up. So this is an extract of the spreadsheet that we have from the Diva test, and this is what schools get. So they can select the items, they get to see the percentages of learners choosing each distractor, they get to see percentages of blank responses, of bad responses, and also the ranking of the items. They can sort the items on all this stuff. And they can also get individual feedback for every learner, for every item. And so they can know how the learner responded or what distractor they chose on every single item. We think this is doable, and certainly we think that it's something that government should be considering, where we put the responsibility and the autonomy with the school and not with the district or with the provincial or national department. And if you want the quick answer to what I said, there are the 3 takeaways. What difference did it make? It just made stuff worse. But that's the end of my presentation. Thanks, Tony.
So thank you very much, Craig. Thank you. Not disappointing at all, as usual. For me, what stood out is, in fact, the question you posed with regards to how to address the knowledge gap and still cover the curriculum. So that's a very important question that I'm taking home from this presentation. But let's then open up for questions. And I would like to start with the question from someone, I think someone present there at the venue. Remember the person who tried to ask you a question when you were presenting? Can we start with that question, please? I didn't hear the question. If you can repeat the question and then answer it. Thank you.
Okay, so what I was you were looking at how to fill the gaps, something like that. And Wits, in a sense, have tried to do this at the beginning of this year, largely because of COVID and so on. But those gaps are there anyway, COVID or no COVID. And I don't know if that fully succeeded in doing what it intended to do, but it was a good effort. Just another comment. Now, I mean, all your comments are great. We see the problem with that at university. But don't you think sometimes it's just the way in which we pose a multiple choice kind of question? If, for example, you take a ratio question, right? Why not pose a question like, is the answer 2 to 1 or 1 to 2? So the person now is not only going, even if the person had a wrong answer, the person will go away from that answering the question maybe a bit more educated. Those other 130s and so on is not going to teach the student anything. It's almost like, you know, this competition, the Who Wants to Be a Millionaire. Let's knock off 2 of the answers. And then suddenly, wait a minute, the answer I was thinking is not there. So I would like those kind of questions to be such that when they walk away from there, they would learn something, even if they didn't know it before that. So a question like, is it 2 to 1 or 1 to 2? Wait a minute, I got to think. That will immediately get the person to think, why was it 2 to 1 or 1 to 2? Instead of thinking about, oh my God, what is it, 135? And what? Same with the geometry question. The geometry question, the perimeter question. That one is, in a sense, should really be told. I mean, it's difficult, I know, in a situation like this. It's classically handled by saying, what is the answer? Work it out. It's not about. It's not going to lend itself nicely to a multiple choice answer.
Indeed.
You see, so I know it's difficult to judge students in this kind of situation, but so we need to look at those kind of things.
Yo, I completely agree with you around bringing the key thing into focus, right? Is it 1 to 2 or 2 to 1 in the ratio? And certainly in the other work that we've done, and Jill and I have talked about this last year, we work a lot with principles from variation theory. And so and the idea behind variation theory is we make small variations in answers, questions, whatever, in order to bring the key thing into focus. And so we would be then saying to teachers, okay, these distractors, kids aren't choosing for the most part. Here's the standout error and its partner if you want. So in this case, the intervention is it 2 to 1 or is it 1 to 2? And in fact, it needs to go 3 to 6 and 6 to 3, and then 2 to 1 and 1 to 2 in that case. But your point is well made. As I had a comment there on one of the slides that said we were looking for a test that was good enough, it would never be perfect. And you know, once you've done the test and you start analyzing the data, you realize all the gremlins that you've allowed to creep in to a test design because you're trying to do it so fast and you're trying to cover this massive amount of content. But as I said there as well, for us the issue is not so much the test, it's what we do after the test. And so one of our key things is now funding permitting to, in a sense, produce a manual that goes with that test that says, okay, if learners choose this answer, this is what they're likely thinking, this is what we suggest you do about it, which gets back to your 1 to 2, 2 to 1. Tony, there was another hand, or maybe even 2 of folk in the room. Can we take those next? Because you're probably not even aware of it.
Okay, no, I can see the hands in the room. But before we take those ones in the room, I see Christine's hand is also up. But I want to take you back to the first point, the person who posed the question made it. I think it was about how do your findings or results compare to the findings pre-COVID?
And the simple answer to that is in the context of grade 8 and 9 in South Africa, we can't tell. Because it's all very well saying what difference did COVID make? It implies that you have the same kind of data pre-COVID. And in a context in South Africa, where the best we have at grade 9 level is the ANA, and the last ANA was written in 2014, and the average mark for it was 10.8%, I think. Basically, it told us nothing. It told us that most kids can't do anything. Probably did more damage than good. So in a true sense, we can't really say to what extent COVID made it worse, because we don't have an accurate measure of what things were like before. But what is interesting is to talk to teachers and ask them what their experience is pre-2020 and now. And that for me has been very insightful in hearing how some of them reflect on what they're facing. Of course, it's anecdotal at this point.
Okay, thank you very much. Christine, if you permit me, can we take the questions from those who are present physically, and then we'll come to you? Because I can see you, but I can't see. Okay, I see you have agreed. Thank you. Craig, can you call on those who have questions to pose? And if I'll ask you please to keep it short, because we only have 5 minutes left.
Thanks.
Thank you, Craig. I love how we sometimes surprise ourselves. things that are expected and the things that are unexpected. So thank you for that. I have 3 questions. One is, you talked about the need to recognize that there are well-resourced schools, but the kids come from under-resourced homes. But how would that have, during COVID, how would it have helped to have funded the schools more? Because I mean, the schools are not providing resources for them at home. And presumably, you're talking about the scenario where they're doing online or at home. Did online work? Did government do online at all? Did it work?
Schools with resources.
Government schools with resources.
Government schools with resources, where the kids had the matching resource or the necessary resources at home, were able to carry on in some way. So online learning happened. When you talk to teachers, they will say, kids were there in front of the computer, whether they learned another question, okay? But they at least had opportunity, whereas other kids had no opportunity. And I need to say no in inverted commas, because the plan was that teachers should have a pack for learners to take home and work on the days when they're not at school. The logistics of that. And if you live far from school and you're not allowed to travel really, the logistics, it's a great idea, but in practice it doesn't really work. But you have more questions.
Yeah, so I'm saying that your idea of resourcing the school better wouldn't solve the COVID problem.
It doesn't solve the COVID problem. What it needs to do is recognize what COVID did, right? So when all the resources are sitting at school and I can't get to school, then in some ways, I'm no different to the learner who has a school where there are very few resources there. And so there's kind of a leveling that's going on there in a very unfortunate way, that's saying the learners who could normally access resources at school didn't have that. That has to have impacted their performance. And I mean, we're going to infer here, and as I said, we don't have results, but when you talk to the teachers in those schools, they tell you loads of stories about what kids could do pre-COVID and what they can't do at the moment. And it's not that they don't have the ability, it's that they didn't have the opportunity. And now the problem is trying to catch up.
Maybe one of your recommendations would be like to really think twice about stopping schools, future versions of
and getting the cell phone companies to come to the party.
Right.
Let's not go
at home. Try to improve the resources at home. Right? Okay.
Okay, sorry, please. Let's take the other question, please, from the second person, because we have 2 minutes left. And then can we take that question and Christine's question together, and Craig can respond to both questions together? Thank you.
I need to go. I have a chat to Eunice Ballum. Eunice Ballum is a previous DVC. And he chaired the whole matric thing after I had exams and so on. And we had a long chat, also on a hike and so on, about situations in schools, particularly the rural areas and so on. I think have a good chat, because he seems to have a grip on the way situations are in.
Thank you. I'll do that. Tony, I'm not sure what Christine's question is, because I can't see it.
Can I ask my question? I actually
Yes,
just want to
please.
say, I think we must really collaborate on this problem. I am at a physics department, and I now have 6 months to work on exactly this problem, but for first years. And when I see your examples, I see some of the examples some of not examples, but some of the problems I also try to address. So I think if we could maybe make contact and work on these type of questions together, because we see that coming through all the way up to university. What we are trying to do at this stage is also similar to what you're saying. We are creating online material, both notes and then multiple choice questions, to take the students back to the basics. No fancy examples, but back to the basics. How does this work? So that's my contribution, and I would really love to talk further about it if anybody is interested.
Christine, you've got my email on the screen, so why don't you pop me an email and we can pick it up. Thank you. Tony, can we squeeze the one more question in?
Okay, let's go for it then. Thank you.
You talked about cluster B not finishing, and yet cluster C did. So I was you said you, I mean,
So finishing, is writing, selecting a response for every item, right? They just put answers down, which says they must have, well, I don't want to pretend I know what it says, but it's kind of, I guess there are two things that I've learned from this. One is the cluster B learners needed more time, and it seemed like it would have made a difference, right? The cluster C learners didn't need more time because probably they were just guessing anyway. So in that sense, you've got to be very careful what we infer from a multiple choice instrument. And obviously you're looking for patterns of random guessing and stuff like that. But it's kind of showing that there's two different modus operandis going on here, where one group is saying, I'm going to concentrate on this and try and do it and answer it correctly. And another group is saying, I'm going to just make sure I put crosses everywhere. And two completely different mindsets in a way, which we need to be aware of and then think about how are we going to address these each individually. And then when you're sitting at university, I'd love to know what happens because you're getting a mix of that. So what happens in Maths 1 if you give them a multiple choice? Do you see these trends of some students making sure there's no blanks? But of course, there's negative marking typically at university, and that impacts things. And that has another dynamic, which we don't have time to discuss because Laura is going to kick me off right now. Tony, over to you.
All right. No, thank you very much, Craig, and thank you to the participants too. It was quite engaging.